Okay, well, good morning, 8th grade. I hope you had a very good Easter weekend with your family. I pray that was refreshing. You're able to focus on the Lord. We're going to go ahead and get started to begin this week on 10.7. So remember, I did the intro video, so this is the lesson here. And this is on combinations. Okay, if you remember, hopefully you watched that video and this will make sense. So combinations versus what we've been doing, which is permutations. Okay, so combinations versus permutations. So the biggest difference here, what I want you to do is to turn to page 429, and look at example 1 with me. Okay, so you need to pause the video, go ahead and turn to page 429 and look at example 1. Okay, so if you look at part A, you see what it says there. It says the number of ways to place 5 pictures in a line. Okay, now the reason that this is a permutation is because the order matters. The order matters. And you may say, why does the order matter? Well, if they're in a 5 in a line, guess what happens? If you use the first one, you can't use that last. If you use the second, then you use the second one, you can't use that for the other 3, right? So it matters in the order, okay? Then we go to B. Look what B says. It says the number of ways to fill 4 8th grade offices from 7. Okay, now think about this. It does matter. So this is a permutation again. Permutation. Why? Because the order matters, right? If I'm trying to fill four spots from 7 people, if I take one of these 7 people and put them in the first slot, I can't put them in the second slot, right? It reduces the number, and so it makes way more combinations total. So again, the order matters. Now, if you need to pause that, go ahead. Lastly here, what happens in step C? So this is the same example, but step C. Look at this one. It says the number of ways to, key word here is choose a 5-person class party from 12 people. Now that sounds very similar, right? Choose a 5-person class from 12 people. But think about this, the order doesn't matter because you're choosing a group. Okay, so then it becomes the order does not matter. And when the order does not matter, then we use combination. Okay, we use combination. So I'm going to go over what that looks like here again. So for combination, what we do is we use the letter C. And the way this works is N, and then we have CR, and that equals N factorial over R factorial times N minus R, all of that factorial. Okay, so if you need to pause and write that down, you maybe should hopefully have that written down from the other time. But I'm going to go over another example that is one that will be like your homework, okay? So let's say they give us this. They give us 6C3. Now what we're going to do here is this 6 is N, so it goes on top, 6 factorial, over, okay, what is R? R is 3, so I just go 3 exclamation point. You see that 3, just took that place of that R. Then I do 6 minus 3 factorial. Okay, so now that equals 6 factorial divided by 3 factorial times 3 factorial. So now, this is the tricky part, I have to write this out. So I do 6 times 5 times 4 times 3 times 2 times 1. All of that divided by, look at this, 3 times 2 times 1 times, that was this one. Now the next one times 3 times 2 times 1. So now what I do is I take my pencil or whatever and I cross out 1s, 2s, and 3s. But look what I'm left with. I have all of this left on the top, right there, and all of this left on the bottom. So now all I do is take a calculator and I multiply those right there. So what is 6 times 5 times 4? So I'm going to do that in a calculator. 6 times 5 times 4. And that equals 6 times 5 times 4 equals 120. Now I do 120 divided by, what's on the bottom here? What is 3 times 2 times 1? That's easy, right? 3 times 2 is 6, times 1 is still 6. What is 120 divided by 6? Type that in your calculators, and you get 30. I'm sorry, not 30. You get 20. Got a little aggressive here. You get 20, right? Does everybody see that? 120 divided by 6 is 20. Now, in permutations, we would have stopped with this one. We would have stopped with 120, right? That would be permutations. But this time, we're trying to figure out how many groups of 6 we have. Okay, we actually only have 20 groups of 6. Okay, if you need to pause that, go ahead. I'm going to do another one here. So let's say that we have 4 choices and only 3 at a time. So that's going to equal 4 factorial over 3 factorial times 4 minus 3 factorial. Okay, that's just the formula. I just punched it in. And I do the top, which is 4 times 3 times 2 times 1. All of that divided by 3 times 2 times 1, right? You see that was this guy right here. Then what is 4 minus 3? Well, that's just 1 factorial. 1 factorial is just 1, right? So now I cross out what's the same? 1, 1, 2, 2, 3, 3. So what I have left on top? 4. What I have left on the bottom? 1. So what is 4 divided by 1? Well, you guessed it. That's 4. So my answer to that one is 4. Okay, not too bad. Now, what happens when I'm trying to decide? Okay, so that's easy. I think you guys can do that. If you watch this video, watch the other video, you'll be good to go. So the hard part is distinguishing between a permutation and a combination. Okay, so I'm going to clear the page and just write this. Hopefully this will help you. So, combination. How do we know when something is a combination? Here's the key part that they do. It's more of an exact sounding. Okay, so these are some of the phrases that they'll often use. Is choosing. Okay, the word is choosing. So if the word that they use is choosing, it's usually a combination. Okay, if they use choosing or the word assigning, choosing, assigning, that's usually when, or even the word picking. Okay, choosing and assigning and a picking, those are more exact words, and so those mean, this right here is all saying that it's a group. Okay, so when we do permutation, right, the key part here is order does not matter. So in permutation, the order does not matter. So the key part to understand there is that when we are doing this, order is important, you are finding permutation. If order is not important, you're finding combination. So actually I wrote that inverse of what I said. Order does matter. I got confused. So the order does matter, and this is because you're doing something in a row, right? If you have this slot can be filled in this slot, and this slot, and this slot, and this slot, and this slot, that's 1, 2, 3, 4, 5, 6 slots, right? So we'd have 6P, and let's say we only had 4 things to put in there, 6P4, or 6P4. You can see if we put 1 here, then it's going to determine that it can't be in these other ones. Okay, if we put 1 here, it can't be in these other ones. So that's when the order does matter. So if it's like in a line or a row, so if you use the word line or order, then it is a permutation. Okay, so this down here in blue is matching permutation. This up here in the black is representing the combination. Okay, so homework for today is on page 430. Can you guys believe it? We've already made it to page 430 on 10.7. And we are doing 1 through 31 odd. That's it. That's all we're doing for the homeworks tonight. So hopefully that doesn't confuse you too much, especially with the other video. I hope that makes sense. Hope all is well as you start this new week. Mr. H is over and out.